So any questions about number one? Do you want me to go over number one? Yeah, because some of you missed number one. All you have to do in problem number one is use FOIL method, okay? So FOIL method, it's first times first, x times x is x squared, outer 6ix, inner negative 6ix, and last negative 36 because it's 6 times 6. I times I is I squared. But that I squared, it's negative 1 times the negative is positive 36. So the equation is y equals, or f of x equals x squared plus 36. And the zeros, well, you let the factor equal to 0. When you let the factor, which in this case is x minus 6i equal to 0, and you solve for x, that's going to be 6i, and then when it's x plus 6i, that becomes negative 6i. So it's positive negative 6i, and that's the function is b. For problem number 2. In number 2, the first thing you need to do is get your solutions. You have to say x is equals to 2, because that's the first one. X is equals to 1 plus 6i, which is this one. And then you forgot about the husband, right? The conjugate. Some of you didn't have the conjugate there. So the conjugate, x equals 1 minus 6i. When you get the factor, you bring the numbers to the left. So that becomes negative 1, 6i becomes negative 6i. On the other one, the 1 moves to the left, so it's negative 1. The negative 6i, when you move it to the left, becomes positive 6i. Now, we have the three factors. Well, this one in factor form is going to be x minus 2. So what I'm going to do is I'm going to multiply those two first. Multiply the two that are the same first. So when you multiply those two, what do? First, you use x and you multiply it by the three of them. Distributive property. So it's x times x is x squared. X times negative 1 is negative x. X times 6i is 6ix. Then it's negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Now notice that I'm putting this in column form. That way I organize my terms. Otherwise it could be messy. Okay, so try to do the same thing in your case. And then negative 1 times 6i, it's negative 6i, so it's right here. Then you do the same thing with the negative 6i. Negative 6i times x is negative 6i. So notice that I went ahead and I put it underneath the positive 6i that I had over here. So it's negative 6ix. Negative 6i times negative 1 is positive 6i. So I'm going to put it underneath the negative 6i that I already have. Negative 6i times positive 6i becomes negative 36. Negative 36i squared. See, it was negative. But then because of the I squared being negative 1, you multiply negative times a negative, and that becomes positive. So I just put it underneath the 1. So I don't have this anymore. I already put it over here. And then it's just a matter of combining like terms. So I bring this down, x squared. These two are negative 2x. This is 37. This cancels out. I don't have this anymore. Then that trinomial, you multiply by x minus 2. So is x squared times x minus 2 is x cubed minus 2x squared. Then negative 2x times x is negative 2x squared. Negative 2x times negative 2 is positive 4x. Then the 37 times x is 37x. 37 times negative 2 is negative 74. And then just combine the like terms. And this is what the answer is. Let me give you a few minutes so you can copy this if you need to copy this. Okay. Right. And we're doing simplifying radicals in geometry. Yes. Okay, so problem number 3. In problem number 3, we just have to review, we have to remember that if the graph passes through the x-axis, that's going to be multiplicity odd number. If the graph touches the x-axis and bounces off, then it's multiplicity even. So at negative 4 is multiplicity odd, and at positive 2 is multiplicity even, so it's B. Number 4. For number 4, it says state how many complex and real zeros the function has. So you know, and believe it or not, but some of you don't know. So let me just come back and retract myself. Complex numbers or complex zeros is you go with the leading term. So whatever the highest degree is, that is the number of complex zeros, which is 2. And now how do we know if it's both real or imaginary or just one real? Well, what you need to be aware of, and if you want to make a note, take notes of this. Let me put it over here. Let me put it over here. Okay. The discriminant. The discriminant is the inside of the square root. When you have y equals, well, x equals negative b plus minus b squared minus 4ac on the quadratic formula over 2a. The discriminant is this part right here. Okay, so if b squared minus 4ac it's equal to 0, what's the conclusion? How many solutions are you going to have and what type? Is it 2? All of this is 0. You only have one solution. Whatever the negative b over 2a is, that's a solution. So this is going to produce one real solution. Okay? If you have b squared minus 4ac, it's greater than 0. Okay, that means that you have a positive number here. So how many solutions are you going to have? 2 real solutions. Okay, 2 real solutions. But if the discriminant, it's less than 0, which means it's a negative number. This is negative. Square root of a negative number gives you what? An imaginary number, but it's plus minus imaginary numbers. So you're going to have how many solutions? 2 imaginary solutions. Okay, so that's how you determine what type of solutions you're going to have. So as you work out the problem here and you end up having plus minus the square root of 13, that produces 2 real solutions. So this is the work. If you don't want to give me the whole work, just give me the discriminant and tell me, the discriminant is positive number, square root of whatever that is, or square root of negative something. That's the work. Okay, so mini, mini, mo, no. And start dancing, no. Show me the work. Okay, so the answer is 2 complex, both real. Yes.
You counted mine wrong.
Do you have the work?
No.
I was looking for the work. So show me the work, please. Okay. So number 5, in problem number 5, it's going to be 3 complex zeros. And how do we get that? Well, by the work in this case is P over the Q. Okay? So it's plus minus 1, plus minus 3, plus minus 9. When you check with synthetic division and you try the numbers, see, let me give you a little tip here, hint. When the last number it's part of one of those possible solutions, start with that number. Because in most cases, that's going to be one of the solutions. Okay, so I started with a positive 9. So when I divide it by 9, that gives me a 0. And when I get that to be 0, then it's x squared plus 1. So when you divide by 9, is 1, 0, 1. This is x squared plus 1 equal to 0. X is equals to plus minus I. So it's 2 imaginary and 1 real solution. So how many complex? 3. How many real? 1. And that's a real. Okay. Number 5 is D. So it's 3 and 1. Number 6, it says find both real and complex. So the complex we know that is 3. So it's 3 complex. And now what's going to be the imaginary or real? Well, you get the P over the Q, and when you start with the 1, you'll find out that the 1 is a solution. So when you divide by 1, you're going to get 1, 0, and 4. Then this is just x squared plus 4 equal to 0. Then you get 4 move over to the right. Then you get the square root of that is plus minus 2i. So this is 2 imaginary, 1 real, and 3 complex. And what are the solutions? Because it says here, find both. Find the zeros. Well, find the solutions. So the solutions are 1 and plus minus 2i. Those are the solutions, okay? The number 7 is B. How do we know it's B? Well, because for domain, you let the denominator equal to 0. X is equals to 11. And the rule says that the domain is everything except for whatever the vertical asymptote is, which is 11. So it's from negative infinitive to 11, and then from 11 to positive infinitive, which is B. And number 8, again, 50% chance. But where's the work? The work is this here. You factored out x parentheses x plus 2, x is equal to 0, x is equals to negative 2. You have your work. You're going to say it cannot be 0, it cannot be negative 2. So it's from negative infinity to negative 2, negative 2 to 0, and 0 to positive infinity, which is A. Okay. On the second page, if you didn't have the graph, this is the graph, and I told you when we went over the notes and we went over the problems, this is the work. This is how you determine the behavior. So you graph it, move it to the left 2 units, that's a vertical asymptote. The denominator exponent is less than the bottom. The numerator exponent is less, because this is x to the 0 power, is less than x to the first power. So it's at y is equal to 0. Then since it's negative 8, it reflects over the x-axis. Once you have your graph, then you can determine what's going to be the behavior. And for this one, it's supposed to be C, but it's not right. How many of you got C? How many of you got C? You got C. Anybody else got C? Anybody else got a C? No? Okay, so what did you get? D is right. Yes. So D over here, it's supposed to be the right answer. As you approach negative 2, it's going to go from the left, it's going to go up. As you approach negative 2 from the right, it's going to go down. So it's D. So I'll go ahead and give you the 3 points to everybody anyways. Okay. So number 10. In problem number 10, getting better, right? In number 10, again, you need to, in this case, you don't have to really graph it. It's just shifted left 4 units, vertical stretched by a factor of 3, and is reflected over the x-axis because of the negative. Now, number 11 is a different story. You have to use long division. Divide it first. Once you divide 2x minus 3 by x plus 5, that's going to be 2 times x is 2x, 2 times 5 is 10. You change the signs, and that gives you negative 13. Then once you get the fraction form, which is this one, is 2 plus negative 13 over x plus 5. This tells you what's going to happen here. Okay, so it's left 5 units, vertical stretched by a factor of 13, reflected over the x-axis, and up 2 units. But you need to divide it first. Problem number 12, the answer is B. As you approach the negative 5 from, this is a negative 5 over here, from the right, positive is right. What is happening? That is going up, positive infinitive. Number 13, vertical asymptote. Just let the denominator equal to 0. that would be plus minus 1. So those are going to be the vertical asymptotes. X equals 1, x equals negative 1. Number 14, some of you came and told me, okay, what's going on here? It's a slant. Okay, well, I don't know. Couldn't tell you. But whenever it's a denominator exponent smaller than the bottom, there's no slant, okay? So please study. All the work for the rest of the problems are on the video. So just in case, okay? Have a wonderful day.